అది ఇది మాత్రం చెప్తాను. సిమెంట్ ఏదైనా చెప్పేసారా? ఓకే, ఇప్పుడు పీరియడ్ చెప్పండి. ఇది లాస్ట్ అది నెక్స్ట్ మీకు సెకండ్ జాయిన్ చేస్తాను. Coming, just wait. Yeah. Good morning, students. So, the functions topic is finished. Right? Don't take much time by doing all difficult level questions right now. Okay? You will have a very good time to prepare the rest of the questions. First, you have to prepare all JEE main and of course advanced also. I have taught a lot, but you don't solve unnecessary questions. That is my point. So limits, Lecture-1. All right. This is another backbone of entire calculus, you can say. So without limits we cannot move ahead to understand continuity of a function or differentiability of a function, or you can say differentiation, or whatever your means applications of derivatives or further in integration. Wherever you go, everywhere you will find a concept of limit. So the notion of limit is very difficult to understand. In fact, means if we go as a theoretical process, the theoretical process of limits of understanding is little bit difficult. So that's why we generally do not teach theoretically in intermediate. Once you get into engineering level, there you will see the theoretical concepts more in limits. So here generally we give the definition, we explain the simple concepts, and we will solve so many questions in limits. So there is a good weightage for the chapter limits in both JEE main as well as JEE advanced, and without limits we cannot understand continuity and differentiability. So this concept limits plays a very vital and wide role in understanding of continuity and differentiability of a function. So let us have a few simple basic words I should explain, which we use frequently in the concepts of limit. So first I will give you a small example regarding limits. Okay, I will take only 2-3 more minutes. For example, you see, this is the target point. Assume this is the target. Okay, suppose an ant is here, and suppose this is 1 meter. Assume this is 1 meter away. Right. So first ant moves half meter in first minute. In next minute it moves, see, it's half of the distance. Next again half of the distance. Next again half of the distance. Next again half of the distance. Like that, it's keep on moving towards this point. Right. So if you observe, these all values are very near to, you can say it is 0. You can assume this is 0. Alright, and it is a 1. Alright, so you can say that It is infinitely number of times that ant moves, and it tries to approach this point. It tries to approach this point, and the distance between this point and this ant will be almost all close to 0, because next to 1 by 32, next to 1 by 64, like that. So which means that we say that ant approaches 0. The ant approaches 0. Since it is approaching from right side, so we saw that that ant approaches 0 from right side. Similarly, ant approaches from left side. You can take like this also. Here one ant. Right. So if ant approaches on a real line from right, we say that ant approaches 0. When do you say that ant approaches 0? When the distance between this point and the ant is infinite small, means is a very small quantity. Very small quantity means you cannot imagine how small it is. Then we say that this ant is very close to 0. So when do we say that we are close to an object? If the distance between the object and a person is almost all tending to 0, then we say that that person is very close to that object. Like that, there are several ways to give the examples of the concept of limit. So in this, the first basic point is neighborhood of a point. So basic terminology. Basic terminology. Remember, this topic also little difficult. If you follow all my concepts and if you solve some 10 to 15 questions per day, 10 to 15 questions per day. Anyway, I will teach this topic 15 days, minimum 15 days. So if you solve 10 to 15 questions per day, definitely you can solve 150 to 200 questions, and I will teach some 100 questions. So totally you will be able to solve 250 questions. Then only you can have the ideas for the new questions. Well, so there are several basic terminology before we start the concept of limits. Right. The first point is the neighborhood of a point. Neighborhood of a point. Alright. So this is the basic concept in entire calculus. This is the basic concept in entire concept. Neighborhood of a point. So what it does mean neighborhood? That neighborhood means anyway, we use that word very frequently in our daily life. For example, you are living in your street, in your house. So those who are living just beside your house, or just in front of your house, or just beside, just behind your house, all are comes under your neighborhoods. Right. Again I am telling, suppose you are living here. You are living here. This is your house. So there is another house, this side and this side, very near to your house, and maybe at the back of your house, and maybe in front of your house. These all houses, this is your house, right? And these are neighborhood houses. Neighborhood houses. I hope you are understanding. So neighborhood means which are very near, which are very near. So the same concept I am explaining here. Let A belongs to R, right? And delta greater than 0 be a very small quantity, very small quantity. Okay, be a very small quantity. All right. Then the neighborhood of A is an open interval, A minus delta comma A plus delta, denoted by n delta here of A. Therefore, the neighborhood of A equal to A minus delta comma A plus delta, which means that I will explain each and every point very clearly. So here you see, this is the point A on real line, right? All right. So the neighborhood of A on the real line means, just to show I am giving this much space, means we are moving a delta distance, very small distance, this side and this side. Then, okay, this is not A, this is delta, and this is also delta, alright? So, this is nothing but A plus delta, this is nothing but A minus delta. So, all the points inside this interval are very near to A, alright? Okay, so here I am writing, we read this as a delta, but actually this is a Kronecker delta. We use very frequently this operator, this symbol. Very frequently, this is a Kronecker delta, because we call this also a delta, right? So there is a lot of difference between these two operators. This delta represents area of triangle, or you can say discriminant of a quadratic equation. There are several things. So now you see, this is the neighborhood. Another word you can say that vicinity of A. Neighborhood of point means vicinity of A. So vicinity of A is A minus delta comma A plus delta. Let us take one example. You take an example. Here you see, suppose this is 1, right? Now choose delta equal to some 10 to the power of minus 10. 10 to the power of minus 10. Then this one, you see, this is 1 plus 10 to the power of minus 10, and this is 1 minus 10 to the power of minus 10. You have to choose the delta as much as possible, very small, positive quantity. Alright, so the neighborhood Okay, the neighborhood, it is denoted by like this. Okay, so neighborhood of a point we also read as simply NBD of a point. We don't write such a big word. Simply we write NBD. So the NBD of 1 is 1 minus delta comma 1 plus delta. If delta equal to 10 to the power of minus 10, then the neighborhood of 1 is simply 1 minus 10 to the power of minus 10, 1 plus 10 to the power of minus 10. Means whatever you take the points in this interval, they are very close to 1. Very close to 1. Like that, you have to decrease the delta values of delta. Then you will get a very good and finest neighborhood. Finest neighborhood. Alright. I will give you one more definition. After that, I will give you the sufficient time to write your notes. Deleted neighborhood of a point. Deleted neighborhood of a point. Alright. So what is the meaning of this deleted neighborhood of a point? It is a very simple concept of neighborhood. If you remove this number A from this interval, that is known as a deleted neighborhood of a point. So let A belongs to R, delta greater than 0. The deleted neighborhood NBD of A is defined as A minus delta open interval comma A plus delta minus set A. Alright, and this I will write like this. Let X belongs to A minus delta comma A plus delta. This is nothing but modulus of X minus A is less than delta. The meaning of this statement is, if X lies in the neighborhood of A, then we write modulus of X minus A less than delta. Means the distance between X and A is always less than delta. Then only X lies in the neighborhood of A. So what is the meant by deleted neighborhood of A? If you remove the point itself from the neighborhood, then it is called deleted neighborhood of A. Alright, denoted by N delta of A minus set A. Nothing else is there. Once we understand the very basic concept of neighborhood, after that everything you can understand. So for example, and see, if X belongs to A minus delta comma A plus delta minus set A, we write 0 less than mod X minus A less than delta. Means the distance between X and A should be greater than 0. Here X can be coincide with A. In that case, the distance between X and A is 0. Right. Here, the distance between X and A cannot be 0. It should be strictly greater than 0, but less than delta. Right. So, I will give you one example. The deleted neighborhood the deleted neighborhood of, to take some number 2 is simply we write 2 minus delta common 2 plus delta minus, from that remove the number. Now you write down. So this is your house. This is your house. So, tell to your friends also, do not neglect these classes. These classes are very, very important, and it is very lucky that you can listen these classes again, maybe on that day or after 2-3 days. Now it is not possible to listen after 1 month. So, even if you see that you can search in any YouTube, nowhere you can see this kind of detailed explanation that I am sure. You won't get any doubt what is this. Everything will be explained very clearly with diagrams if required. So, deleted neighborhood of the point is over. Now, what is the meaning of approaches or tends to? Meaning of approaches or tends to. A. Meaning of approaches or tends to A. Okay? So here you see. Let X belongs to R. Alright? Okay? and A belongs to R. Alright? Okay? If X approaches, or tends to X approaches or tends to A, denoted by or written as, right, let X belongs to R, A belongs to R. X approaches or tends to A, written as X tends to A. Right. Okay. X approaches or tends to A, written as this. Means X assumes all values. X assumes all values in the deleted neighborhood of a point A. In the deleted neighborhood of a point. In the deleted neighborhood of A. X approaches or tends to A, written as like this, means X assumes all values in the deleted neighborhood of A. So therefore X approaches A implies if and only if you can say, see, X takes all values. X takes all values in the deleted neighborhood of A. 0 less than mod X minus A less than delta, which means that in another way we write that X belongs to A minus delta comma A plus delta, deleted neighborhood minus set. Delta is a very small quantity. I need not to tell it again and again. That is already told in the beginning. Right? So, if X approaches A means if X assumes all values in the deleted neighborhood of A. In the deleted neighborhood of A, which means that you see this is the point A. Now X is approaching. This is known as a right approach and this is known as a left approach. Left approach. Alright? This is a right approach. Right approach. Right? So, this is assume that it should start somewhere. It should start somewhere. So it starts at a distance of delta. So this is A minus delta. A plus. And this is A minus delta. Like this. So which means that X is moving. X is moving this point A. X is moving this point A in the both directions. Right? For example, you can say that one car is moving towards a house. Another car is moving towards that same house in the opposite direction. Right? So both are approaching the same house. So here X tends to A means X takes so many infinite values which are very near to A but not A. Which are very near to A but not A. So X tends to A means X belongs to A minus delta to A plus delta minus set A means X will never takes the value A. You write down. So these are the basic terminology. It is very difficult to explain to the intermediate first year students. It is not easy task. So therefore, x tends to a. Right, x tends to a implies x not equal to a, and x is very near to a. You can't say that. So x takes all values in the vicinity of a. X takes all values. X takes the values in the vicinity of a. In the vicinity of a. I hope you are understanding. Okay, see. If x assumes, or I can say that, x approaches a from right. X approaches a from right. We write x tends to a plus. So whenever we write x tends to a plus means we are approaching that number a from right side. You got my point? So therefore, x tends to a plus implies x belongs to a plus delta. This is a plus delta. It is approaching from right side. Similarly, x approaches a from left. We write x tends to a minus. So therefore, here I am drawing the line also. This is a and this is a minus delta. You see, we are approaching a from left. Alright. Okay. So therefore, x tends to a minus implies x belongs to a minus delta to a. That's over. You got my point? Okay? Right. So fourth one, if, right? So x means x approaches a implies x tends to a minus and x tends to a plus. X tends to a implies x tends to a minus and x tends to a plus. You write down. Well, so neighborhood of a point is over, deleted neighborhood of a point is over, meaning of approaches of tends to A is also over. So like that gradually we will build up the concepts of limit. We start at a very ground level and we will develop gradually. So this I am removing. All right. What is the meaning of x approaches 1? So an example, here you see x approaches 1, which means that here you see first I will take that here x values I am taking, all right, and means we are approaching to 1. All right, so here I can take, I will start somewhere, I will give you a few values, 0, 0, 0, 0, 0, 1, all right, okay, like this, okay, 1 point, 1, 2, 3, 4, 5, 6, I am making it 5 zeros now. All right, and all right, so the distance between not 5 zeros, I have to start with 7 zeros. So when you are increasing these zeros, which means that you are very close to 1 from right side, right, like this, you are approaching 1 from right side. You take 0.999. You start here. Next 0.9999999. Next 0. You take more nines, more nines, more nines, so and so on. You are approaching 1 from left side. You are approaching 1 from left side. So x tends to 1 means x not equal to 1, x belongs to 1 minus delta to 1 plus delta, which means that it takes all values in the neighborhood of 1, in the deleted neighborhood of 1. Very close, very close. X can be here, here, wherever it is. Alright, okay. So now I can give you the definition of concept of limits. All right, okay. So now, basic concept of limit. Basic concept of limit. First, I will explain through the example. After that, I will give the definition. Right? Okay. Consider f of x equal, you take that x square minus 1 by x minus 1. Alright, okay. Now you see clearly that f is not defined. F is not defined at x equal to 1. Alright, so therefore for x not equal to 1, you will have that f of x equal to x plus 1. Alright. So, usually even though the function is not defined at x equal to 1, but we will have a curiosity that what will be the approaching value of x plus 1 as we approach 1. If x approaches 1, then to what value that x plus 1 will approach. That kind of curiosity we may have. Alright. So, even though function is not defined at 1, but what will be the values of function when x approaches 1? When x approaches 1. So, x approaches 1 means x is not equal to 1. So, which means that we will study that the values of x plus 1 in the vicinity of, in the deleted neighborhood of 1. Right? So, okay, so what means now I am writing this, see, as x approaches to 1, which means that x not equal to 1, right? And of course x belongs to 1 minus delta comma 1 plus delta. As x approaches to 1, remember you can add 1 here, 1 plus x approaches to 2. So this implies f of x approaches to 2. So as x approaches 1, this function approaches 2. This 2 is called the limit of f. 2 is called the limit of f as x approaches to 1. You got my point? Written as we write limit x tends to 1. Here you see x tends to 1, f of x equal to the value is 2. So the meaning of this case is this f of x approaches to 2. Sometimes may be equal to 2, sometimes approaches to 2. Or we write simply LT x approaches 1, f of x equal to limit x tends to 1, x square minus 1 by x minus 1. Limit x tends to 1. X tends to 1 means x not equal to 1. So you can cancel x minus 1. Then you will get x plus 1. You can substitute that x approaches 1 here. You will get 1 plus 1. That's equal to 2. So 2 is the limit value of f. It is not functional value. Therefore, here I am writing. Therefore, 2 is the limit value. Of f, but not functional value. Right? So 2 is called limit value. 2 is called limit value of f at x equal to 1, but not functional value. I will explain in detailed way. This I am removing. Okay, in detailed way once again I will explain that how f of x approaches 2. Here you see x approaches 1, right? So here I am writing that x value is just a moment. Yeah, I hope it is visible, right? Everything is under control. Yeah, x approaches 1 means alright. Here f of x. Suppose x approaches 1 plus. X approaches 1 plus. X approaches 1 plus means you have to take the value just greater than 1. So, this implies x takes values just greater than 1. Just greater than 1. Important. So, you take that 1.001. You take this. Then what will be f of x values? You will get 2.001. If it is 1.000001, then it will be 2 point like this. Alright. Okay. So in this way, you are approaching 1 plus right side. Now here you see this value is decreasing, which means that you are approaching 2 plus. So when x approaches to 1 plus, that f of x equal to x plus 1 approaches 2 plus. Now you take x approaches 1 minus. Means x takes values just less than 1. Just less than 1. Alright. Okay, here I am writing 0.999. Then what will be the f of x? It will be 1.999. Alright. Again 0 point. You take more 9. When you assume more 9s, you are close to 1 from left side. Then what will be f of x? 1, 2, 3, 4, 5, 6, 7, 8. This and so on. When you are keep on increasing these lines, which means that you are very close to 1 from left side. Right? And at the same time, function also approaches 2 minus. Therefore, as x approaches 1, you see, when do you say that as x approaches 1? When x approaches 1 from left as well as from right. So f of x also approaches to from right and left. F of x approaches 2. Therefore, limit x tends to 1. F of x, we say that exists and equal to 2. And equal to 2. The reason I have started this chapter today is because that beginning means introduction takes time. So I can't keep on postponing. Anyway, I have taken a lot of days to teach the function. Actually, in fact, that much is not necessary. But anyway, over I have taken. So that's why I have started this topic little earlier. I hope you are understanding this kind of approach. This kind of approach is not getting into your brain. Then little struggle will be there in the further classes. So better you try to understand very clearly. You copy it now. Alright, I hope you are understanding. So, I write the definition and I will leave you. So now here you see the definition. There are actually, in fact, there are informal definition of limit. Informal definition of limit. Alright, you see, let f of x be a real valued function. Be a real function. Right? Okay. Now, f of x is said to approach A. You can say the f of x is said to approach a number L. A number L belongs to R. A number L belongs to R. Okay. Now f of x is said to approach a number L belongs to R. We can write that is L is the limit of f of x. L is the limit of f of x. Okay, as x approaches A. As x approaches A, we write like this. Okay, written as limit x tends to A, f of x equal to L. If I am writing here, if f of x can be made arbitrarily close, to L. F of x can be made arbitrarily close to L. I will write in another way. That is the absolute difference between the absolute difference between f of x and L. That is modulus of f of x minus L can be made as small as we can, please. Can be made as small as we can. As small as we can. As small as we please. Or we require. Again I am telling, let f of x be a real function. Now f of x is said to approach a number L belongs to R as x approaches A, written as like this. If f of x can be made arbitrarily close to L, that means the absolute difference between f of x and L can be made as small as we please. Means how much close you want to do, that much close if f of x approaches to L, then we say that the limit of f of x is L as x approaches That's full stop. Following my point, f of x can be made as arbitrarily close to L. Here I will be pleased as x approaches A. As x approaches A. If you read this sentence 10 times, then also you will have several doubts. What is the meaning of each word? You have to read the definition very clearly. Once again I am telling you, see, when do you say that a function approaches to L? When do you say that a function approaches to L as x approaches A? If in the beginning only I told you that a person is approaching an object. A person is approaching an object, right? This is an object. He is moving towards this object with some restrictions. So, when do you say that this person is approaching this object? When the distance between that person and this object is as much small as we can. Means there should be almost a negligible distance between object and person. Then only we say that person is approaching this object. So the same way, f of x, we say that f of x tends to L. F of x tends to L if this difference can be made as small as we please. As small as we please means we require, I want the distance, I want the difference between them is less than 10 power minus 10. The difference between these two less than 10 power minus 100. I want. So however you want, if you can show that, then f of x approaches L. Right. Thank you. Okay. We'll teach. We'll continue the same thing, but another class and another 2 classes will take only to explain the concepts. Right. Problems anybody can do. That's not a matter. Thank you. We'll meet again.